Welcome to the lesson for today. I'm going to talk about evidence and some more evidence. Well, this is actually this is the lesson for today. It's a question that we are supposed to answer. It's actually the GCES or O-level physics question. So the drag lift pulls the scale from the bottom to the top of a sky slope. The arrows A, B, C, D represent the forces acting on the skier and her skis. So it shows here actually how she's moving up the slope. So which arrow represents the force pulling the skier up the slope? So I'm going to represent here really. If you have a slope, and then you have a mass. Say this mass is being pulled upwards with a force. It means to the plane here, which is actually vertical to the plane, you have the normal force. And then down, you have the weight. And on the other side, you have the other force, which is opposing the normal force. And so looking at this question, you notice that which arrow represents the force pulling the skier upward. So D is actually, D here is the force which is pulling the skier upwards because it's going up just like this force here. Number two, which arrow represents the normal force? As I've indicated, the normal force is always perpendicular to the plane. So here is our object. We have the weight. And then vertical to the plane, we are going to have the normal force. And so what we have is actually the normal force in this case is actually C. Okay. And this F, as we indicated, D is the force, which is actually pulling the object going up the slope, which is D. And the second question, which force represents actually is the normal force. The normal force here, as we have indicated, it is actually C. C is the normal force. So C is the normal force. The drag lift pulls the skier with a constant resultant force. So the resultant force, we are told the resultant force is actually 300 newtons for a distance of, the distance is 45 meters. Calculate the wake. We are aware that wake is equal to force multiplied by distance. And so our force here will be the resultant force, which is equal to 300 newtons multiplied by the distance, which is 45 meters. And this gives us actually 13,500, 1,300, 1,350, 1,000, 13,500 joules. So this is the work which is actually done by moving the object upwards. At the top of the slope, the skier lifts the drag lift and skis back to the bottom of the slope. The graph below shows how the velocity of the skier changes with time as the skier moves down the slope. So this is the graph, which is velocity against time. So as we can see from the graph, after 50 seconds, the skier starts to slow down. The skier actually decelerates at a constant rate, coming to a stop in 15 seconds. Draw a line to show the change in the velocity of the skier as he slows down and comes to a stop. So from 50 seconds, you have to, this is 13 actual meters per second, and it decelerates straight. So from here, this is 10 seconds. So the 15 seconds would be, this is 2, 4, it will be here. So you draw a straight line to that point. So this is the deceleration, and this is the graph that they wanted us to draw. I thank you.